Then the disadvantage of the structured SDLC are the downfalls include many of the methods are considered inflexible and some suffer from outdated processes. Some of the methods that we are using may not be flexible enough because it's more like it's rigid, and which of course may have effect on the output of the system that is developed. Since you base the plan on requirements and assumption made well ahead of the project's deployment, many practitioners identify difficulties in responding to changes circumstances in the life cycle. It's a life cycle, and it's more like after this you do this, after this you do this, just like the cycle that we showed you on the previous slide. So because it's not flexible, there may be problem for users to adapt to many of these rigid plan. Some consider the structured nature of the SDLC to be time and cost prohibitive, because like I said, there will always be timeline for many of these stage phases that we are talking about. The so users may consider the structured nature of the SDLC to be time prohibitive, the cost prohibitive, that it doesn't allow you to waste unnecessary time, and it doesn't allow spending unnecessary amounts for hardware or software procurement. Some things find it too complex to estimate costs, are unable to define details early on in the project, and do not like rigidly defined requirements. Like I said before, because of its complexity, it may be very difficult for you to actually estimate the cost. Then testing at the end of the life cycle is not favorable to all development teams. Many prefer to test throughout their process. Every process we need to test, but unfortunately the testing may involve at the end of the life cycle, which of course may not be favorable. The documentation involved in a structured SDLC approach can be overwhelming. For every phase there must be documentation, and which of course may make it to be too cumbersome or overwhelmingly, you know, it may be discouraging. Teams who prefer to move between stages quickly and even move back to a previous phase find this approach challenging, because you move to and fro, most especially during the documentation. You look at every phase, it will be documented. All these things may be very discouraging because every stage there must be documentation. Then on this slide we are looking at other forms or method of SDLC or models. There are several models. There are several methods in which you can implement SDLC, and some of them are mentioned there. But before we go there, let's just look at the paraphrase of preamble. When the word system is replaced with the word software, it creates another version of LDLC. The system development lifecycle follows an international standard known as ISO 12207-2008. In this standard, phases similar to the traditional systems development lifecycle is outlined to include the acquisition of software, development of new software, operation of that new software, the maintenance of that new software, and of course disposal of the software products, and identify area of growing concern and increased adoption continues to revolve around the need for enhanced security, functionality, and data protection. Like system development lifecycle discussed previously, there are numerous methods and frameworks that can be adopted for system development, and some of them are what we are going to discuss. Number one is the waterfall model, and it's a steady sequence of activity that flows in a downward direction, much like its name. It's a traditional engineering process that closes each phase upon completion, and is often criticized for being too rigid. Like the phases that we may mention: feasibility stage, design stage, But all these phase, they are they have to get to completion before you can move to another phase. Then we have another model, the V-shaped model. Is an adaptation of waterfall that has testing as an integral part of to close each phase. For V-shape, for every phase, there's a need for you to test before you move further. Then another the third one is a prototype model, which of course advocates a plan to build numerous software's method that allows different elements to be tried out before fully developing them. The prototype method can increase buy-in by users and customers. So there are various ways that have been, very technical ways that can still be used for achieving the same purpose. And with that, you'll be able to know, okay, this one is better than this one is faster, or this one is cost effective. Then another one, the fourth one, is the rapid application development. Is another model. It's an hybrid of the prototype method, but works to de-emphasize initial planning to rapidly prototype and test potential solutions. So this one involves the testing of every of the planning stage, and is a prototype of the one that we have discussed before. Then again, the spiral method. This one involves process steps which are graphically viewed in form of a spiral formation, and is generally credited to provide greater flexibility and provide adaptation. This is in form of a spiral. As the process goes on, you are moving around and you are looking at what actually is being achieved for every phase, and you monitor every phase of that development, of that system development. Then last the list of this method that we are looking at is the agile method, and they are software based system that provide feedback through an iterative process. And some of them are Kanban, Scrum, extreme programming, dynamic system development method. They are all based on software. Software are involved in the building up this life cycle. Other methods and methods that are also available are dynamic systems development, big bang model, Fontaine, evolutionary, prototyping model, uh, among others. Each has elements of a defined step process with variations to adapt for flexibility. Then the important thing that should be our concern is choosing the right SDLC model is a critical issue for the system to be for any new system that we are building to be successful. So there's not a hard or fast rule. There isn't any hard and fast rule that you must choose or on a single methodology for each project. But if you are able to invest in a methodology and the supporting tools which will benefit so much on the system that you are building, that will be better for it will be the right methodology that will be better for that particular system. Then we need to understand the various methodology, the advantages and disadvantages before we can say this model will be good for this particular system. And then we need to understand, be familiar with the team dynamics, the stakeholders involved, and the project, the management of this project. Also, we should be able to compare the methodology for the team vis-a-vis the facts, the size of the team, the type of the technology project, the complexity of the project, and the method. All these ones will be the functions that will determine the kind of model that will be used. And again, we need to share the decision and the reasoning with the team and the stakeholder. That is very, very important. You cannot just say you are the alpha and omega of any system you are building. Then on from this, we move to project managing. How do we now manage the project in the SDLC? the iterative method. Don't forget that in the iterative method and the phase stage of the SDLC, you keep on, or you keep on trying the system based on the phase, and you repeat that particular phase. Like for instance, when you say the maintenance phase, you vary the interest of the user. You consider the interest of the user. You try, and when the interest of the user varies, you still continue to try it, and until you have an optimal result. The major goal of the SDS is to provide cost-effective and appropriate enhancements or changes to the information system that meet overall corporate goal. That is the ultimate thing of the SDLC. Come what may, whatever design method we have used, we need to have it in mind that it must be cost effective, as well as the goal and the objective for which the system is being built must be met. Then the proper manager, project manager, is responsible for executing and closing all the linear steps of planning, building, and maintaining the new or improved system throughout the process. Other methods for the project management involve administration of human elements, including communication. The project manager must be involved in the administration of the human elements, the communication, changing their management strategy, the training, initiating and driving the planning for the project, setting and monitoring goals, providing avenues for the communication and training, and keeping track of budgets and timelines. The project manager is the overall control agent for the strong SDLC process. So the project manager has a very important task to play, or role to play, when it comes to SDLC, because he is in control. He knows how he has to balance in terms of manpower, in terms of the technical know-how, in terms of who and who are important for every phase or for every stage of the design, such that don't forget the issue of the cost effectiveness, as well as being able to manage the information, and to be able to get the objective of the corporate goals of the organization, is the role of the of the project manager. Then again, the software solutions that support the SDLC is the role, as again, of the project manager. The SDLC products for software vendors promise organization clarity, model process development procedures, legacy, application strategies, and improved security features. All these are different SDLC products. Many options provide customized or integrated solutions. Vendors such as Oracle, Airbrake, Veracode provide software development solutions in their complete enterprise software offerings. Many of these vendors also have a strong focus on identifying and debugging systems that may support the process of testing in software development lifecycle. In many cases, SDLC teams utilize a variety of software solutions to support the varying stages. What is we are saying here is that there are some software solutions that can actually be used to help us and strengthen the software that we are building. And some of them are what we have mentioned as the vendors. And their main focus there is to make the system to be more robust. Then, regardless of the process implemented and the tools used, all require the crucial element of documentation to support findings. For everything that has done in the system development, there must be documentation. Close iterative phases and to analyze system sources. Today's increasing demand for data and information security also factor into the overall planning, training, testing, and deployment of a system. However, one of the most important elements of success of any SDLC method continues to be in the initial planning, followed by choosing the appropriate framework and method, and finally thinking to deploying and maintaining a robust project planning. And what this one is just talking about is that It doesn't matter where the process that are implemented, the tools that are used, and any other crucial element that but there must be documentation of every finding, the steps that are involved, and the result that have been were that we are able to get. Then the project manager in charge of the SDLC needs the right tools to help manage the entire process, provide visibility to key stakeholders, and create a central repository of documentation created during each phase. One such tool is Smart Sheets, a work management and automation platform that enables enterprises and teams to work better. With its customizable spreadsheet interface and powerful collaboration features, Smart Sheet allows for streamlined project and process management. So these are the tools that can support our SDLC life cycle. They are in form of a template, and they are important, which of course will help us in the area of development, testing, deployment, and creating a timeline. All these things, they will actually work together in getting a robust SDLC, and which of course we can share our plan with our. Don't forget that decision making here is not just about you alone. It's a teamwork, because no one can build up a system. Then in this section 8, a kind of recap of what you have done in this section 8, we have been able to examine the system development life cycle and highlighted the system steps involved in the process of setting up a system, and also the advantage and disadvantage of any system that we are being able to set up. Then we identify some of the models, which are basically a variation in the order of arrangement of the identified phases of steps of SDLC, as it's been explained during the course of our class. Then we look at the history of the SDLC, and we try to review, and finally the softwares or tools that can be used to manage the process of was were able to identified. Thank you for listening.